friends. In this video, we'll be discussing about this ring. Okay, let me just choose a color. I'm going with blue. Okay, so this ring is a really special ring, as I said last time. It gives you lots of example to us, lots of counter example, lots of examples, right? So before starting, let me just define this set properly. So my z square root of d is nothing but set of all element of the form a plus square root of d b, where this a and b are nothing but integers. Also, what is the d? D is also an integer. It could be a positive, negative number, anything. But you need to make sure d is not divisible by a square of a prime. That means I cannot take my d is equal to 18 because my 9 divides it. Why we cannot take it? Because if I take square root of d, then square root of 18 is actually same as 3 square root of 2. Correct. So we just wanted it to be a most simplified version of this root. Hence, we are considering d is not divisible by square of the prime. The simple reason is if I consider z square root of 18, z square root of 18, then it is actually same as z square root of 2. So there should not be any overlapping like this. Hence, we are considering d is such an integer such that it is not divisible by square of any prime. Okay. Now, in this ring, okay, definitely students can verify it as a commutative ring with unity. We have done it for a particular case, d is equal to -5 in the last video, but student can verify this is also a commutative ring with unity. On this ring, we are defining a function. The name of the function is a norm, and it is from z square root of d to a real numbers. Definitely, it has some elements inside this which are not used. You can see after the definition, which is defined by what it will do, this function will take any element a plus square root of db to where it will take it to mod of a square minus db square. You will see only over here we will use positive real numbers including 0. Okay, so definitely the range is r plus, but for now I don't want to go inside the case of the range, but now I define the map as a plus square root of db, which is same as square root mod of a square minus db square. Okay, this is definitely a function because we know for every single input there is a unique output, so it is definitely a function. Why we are so much interested in this norm function? Because this norm function has a special properties which will help us to prove so many things inside this ring. Also, since we are going to prove this properties of the norm in general, we can apply this property for every d such that d is not divisible by square of any prime, right? And d is what? Any integer which satisfies this property. So whatever property we are going to prove, we can apply it in a majority of the cases. Hence, this is really important. Okay. So the first property that we are going to prove is nothing but my n of x will be equal to 0 if and only if my x is equal to 0, where what is this x, where x is actually nothing but a plus square root of db, which is some element of z square root of d. So I'm trying to say that my norm will take any element to 0 if and only if that element is 0. Means this function is taking 0 to 0. No other element will get mapped to 0. Okay, simple idea. We need to prove this. We'll prove three properties. The first one is this. Once we'll prove this, then we'll think about the second property. So let us just prove this. I suppose, since I need to prove if and only if, I suppose the one part, suppose my n of x is equal to 0. Okay. That means what? That means my mod of a square minus db square is equal to 0. Okay. We know that mod of something is equal to 0 if and only if that something must be equal to 0. Okay. That means mod is equal to 0. That means that number must be equal to 0. Now, also, I can divide this into two parts as a minus root db times a plus root db, and that it is equal to 0. Correct? Yes or no? Okay, so now I know this is a number, this is a complex number, right? This will be a complex number. It may be a real number, it may be an integer, it could be anything, but definitely it is inside complex number. The product of two complex number is equal to 0 implies me either of them must be equal to 0. That means my a minus root d b must be equal to 0, or my a plus root d b must be equal to 0. Okay, when I can say my this is equal to 0, that means what? I know my a and b are integer, d is some integer which is such that p square does not divide d for any prime. So this is equal to 0 means what? This is nothing but what? This is nothing but additive identity of this ring. Of what ring? Z square root of d. Also, we know that the additive identity is unique. By using that property, what I'll do, this is same as 0 plus square root of d 0. Similarly, 0 plus square root of d0. Now what I will do, I just compare them. Okay, if I compare them, I'll get, in the first case, I'll get a is equal to 0, or and my b is also equal to 0. If this is the case, actually we are done. If this is the case, then my a plus root db is actually nothing but my x, and that is equal to 0. So this case was already done. Okay, but from this I know that if my a and b both are 0, by comparing I know if my a and b both are 0, this implies me my a plus root db will also be equal to 0. Correct? Okay. So in both the cases I found my x must be equal to 0. I started with my norm is equal to 0, and in both the case I found my x is also equal to 0. So one way is okay. The second way is actually much trivial. Conversely, this is a notation for conversely. If I do the back arrow, conversely I will suppose my x is equal to 0. What is my x? X is nothing but a plus root db, and that is equal to 0. This thing implies me what? This thing implies me my a is equal to 0 and my b is equal to 0. If my a and b is equal to 0, then what is the value of a square minus db square? Right? What is the value of a square minus db square? Yes, it is equal to 0 square minus db square. You can directly write this is same as equal to 0. Therefore, my mod of a square minus db square is also equal to 0. Right? That means my norm of a plus root db is also equal to 0. Therefore, my norm of x equal to 0. Correct? So now we know, therefore, now we know, since we prove both the way, my nx, that norm of x will be 0 if and only if that element is 0. Otherwise, it is not possible. Okay? So this was the first property. We'll go for the second property. This is about distributivity of a norm over a multiplication. That means my norm of xy is same as norm of x times norm of y, where my x and y, are any elements inside z square root of d. Okay. So we need to prove this. It's really simple. We just have to play with that function, nothing else. Okay. So let my x is equal to a plus b root d. Okay, I'll just write okay. And my y is nothing but alpha plus beta root d. Okay. Now I'll consider my left hand side. It is nothing but norm of xy is same as my norm of a plus b root d bracket multiply alpha plus beta root d. Okay. For those students who can prove this, they can convert the speed of the video to 2x, 2 times the normal speed, because this will take some time. Okay, so it is normal. Okay, I'll just multiply this. It will become alpha beta, then it will become plus b beta d plus root d times beta alpha plus a beta. I hope I'm right. Okay, so now I know the norm will be defined by mod of the first part is nothing but this beta d square minus d times the second part is nothing but beta alpha plus a beta square. Now what we have to do? We just have to square them. Okay, let us just square. Okay, it is nothing but a square alpha square plus 2 times alpha beta abd plus beta square b square beta square d square. Okay, after that I'll just write it over here. So it is minus d times beta square alpha square plus 2 times uh, alpha beta a b plus a square b beta square, right? Okay, now we will open the bracket and let's see what can we simplify. It is same as a square alpha square plus 2 alpha beta a b d plus beta square d square minus b square d alpha square minus 2 times alpha beta a b d minus a square beta square d. Okay. So this is something that we got. Okay, you can see this two part, this two things are same but in opposite sides, so I can cancel them. So ultimately what I get is a square alpha square plus beta square b square beta square d square minus d times what? From this two I can take minus d common. I get beta square alpha square plus a square beta square. Okay. Let us just see this what I can do. So this is nothing but my left hand side, that is nxy. Now let me see my right hand side, that is nx into ny. Okay. So my nx is what? Nx is nothing but a plus n of a plus root db, and that is nothing but n of alpha plus root d beta. I'll just simplify this and let's see what happens. So it is nothing but a square minus d b square times alpha square minus d beta square. Since we know norm is multiplicative, this mod is multiplicative, that means I can write this is same as mod of the product of these two. So it is alpha square minus db square times alpha square. Sorry, every time I'm reading a and b as alpha and beta, but I hope you guys will get it. Okay, no issue. So it is a square alpha square minus a square d times beta square minus d beta square alpha square plus d square beta square, and this is also beta square, right? You see both of this thing, this one is same as, actually same as 2, correct? From this 2 you can take d common and you get this thing, right? So since my 1 is same as 2, implies me my n of xy is same as n of x times n of y. Okay. Definitely students can think where we are going to use it. Is it so trivial? But this proof will going to help us to prove the unit of the set z square root of minus y is infinite set. Since suppose by after proving the third property, you will get why it is so much important property, the second one. But for now I know my n of xy is same as n of x into n of y. Okay? This is nothing but the second property. Let's go talk about the third property, and the most important one I will say. There is a n of x will be equal to 1, that is that norm part will be equal to 1 if and only if, you guys can guess it, it will be equal to 1 if and only if my x is the unit of my z square root of d. That means I can conclude that my x has an inverse inside this if and only if the norm value of x is equal to 1, otherwise not. So it is a really good way. This norm functions give us so good result, right? If you check a element, it's just as unit or not, you just need to find out its norm. If the norm is 1, you're done. Correct? Okay. So we'll just prove this thing. Let us start from one way. That suppose my n of x, that is same as my x value is nothing but a plus root db, and that is equal to 1. That means what? This implies me my norm of a square minus dv square, and that is equal to 1, right? Now we know mod of some real number will be equal to 1 if and only if that real number is same as what? It could be 1 or it could be minus 1 also. So I got to know my a square minus db square value is plus or minus 1. Now those students who have watched my previous video, they know where I'm going, right? So a square minus db square is equal to plus or minus 1. They know something what I'm going to do after this. Right? My claim is I want to prove that my x is a unit. X is a unit if I know inverse of it is an element of z square root of d. So I just need to prove inverse is an element of it. Let me just consider inverse of it. Consider x inverse, that is same as a plus root db inverse, and that will be same as 1 divided by a plus root db. What I'll do, it is same as what? I'll just multiply it by a minus root db, the conjugate part of it, so that I can simplify it, a minus root d times b. Okay. So now what is this same as? This is same as my a minus root d times b divided by, this is a square minus b square formula, right? A into b, a plus b, so it is same as a square minus db square. I'll just split this thing into both the parts, that is nothing but a divided by a square minus db square plus root d times minus b divided by a square minus db square. Okay, so you will see now from this I know that my denominator is actually nothing but plus or minus 1, right? So what will be the value of this? Value of this could be plus or minus a plus root d times plus or minus b. Since I know my denominator is nothing but plus or minus 1, correct? Okay. Now this x inverse, will it be an element of z square root of d? Yes or no? You just have to think about it. I know my a and b are nothing but integer. Whatever it be, if it is plus or minus, or it is plus a or minus a, over here also same, it is plus a or minus a. In either case, I know since my a is an integer, plus or minus a is also an integer. Similarly, b is an integer, implies plus or minus b is also an integer. Hence, since this part and this part is an element of D, and I know how the elements of this ring look like, so it is the same thing, right? So from this, I found that my x inverse is an element of z square root of D, right? Since the inverse exists and it is element of z square root of d, this implies me my x is the unit. Okay, so this way was actually trivial way. We'll think about the converse part. Conversely, suppose my x is the unit. I need to prove my norm of x to show that my norm of x, that is same as my norm of a plus root db, that is actually same as mod of a square minus db square is equal to 1. I need to show this. Okay, this I know the norm will be 1. That is to show that my a square minus dv square is equal to plus or minus 1. So my target is to prove this. I already know that my x is a unit. Okay, so let's just start thinking about it again. Okay, suppose x is a unit, so my x is actually same as x inverse is an element of, since it is a unit, I know x inverse is an element of z square root of d. Correct. So what is the inverse? We just now we found my inverse is same as this, right? So I'm just using it. So x inverse is actually same as, therefore my a divided by a square minus db square plus root d minus b divided by a square minus db square is an element of z square root of d. For those students who has watched my last video, they know after this what we are doing, right? Because similar thing I have done in the last video, I'm repeating again. Or for that case, we have d is equal to minus 5, nothing else. So I'm just repeating those steps, but in general case now. Okay, so I know this is an element of z root d if and only if my this part and this part is nothing but integer, right? So therefore my a divided by a square minus db square and minus b divided by a square minus db square is nothing but element of z. So I consider it's a sum name. So it is a by a square minus db square is equal to p, and minus b by a square minus db square is equal to q, where p and q are what? I know they were integers, so I just give them a name p and q. Okay. From this I can write my a same as p times a square minus db square. Okay, and I can write my b same as minus q times a square minus db square. Now, similarly, I'm going to consider my a plus root db. I know what it is. I know it is actually same as x, but now I will use the value of a and b, which I found just now, right? So value of a is nothing but this value. I'm just using it. On the place of a, I'm writing p times a square minus db square. Then plus root d as it is, I'm writing plus root d as it is. On the place of b, I will write its value, that is minus q times a square minus db square. Okay, is it fine? Okay, now after this I can take this thing common from both of them, so I get a square minus db square times p minus q times root d. Okay, so since you are 2i BSc student, I don't need to explain such a small steps, but if you have any difficulty, just let me know in the comment section. Okay, root d b. Okay, now I will use a square minus b square formula over here, so it is a minus root db, a plus root db, p minus q root d. Okay, now since what I started with x is a unit, hence x cannot be a 0. Correct, that means what I started with this x, that means my x is a unit, x inverse exists, that means x is not 0. Hence what I can do is I can cancel this part from both the sides. Since x is not equal to 0, I can cancel. This is a really trivial thing, right? X is not equal to 0, hence only I can cancel. Therefore my 1 is same as a minus root db times p minus q root d. Correct? Okay, this is nothing but my equation Roman 1. Okay, similarly I will start with a minus root db, that will be same as something, that will be same as p times a square minus, I'm just using the same thing, a square minus db square minus root d times minus q times a square minus db square. I will follow the same steps, and ultimately I will find out that my 1 is same as, this part is on homework for all of you, that's few steps. You will find out that 1 is same as a plus root db p plus q root d. I'm just writing ahead. Okay, no issue. So this 1 and 2 are really important equations for us. If I just multiply this 1 with 2, what I get? I get right hand side is nothing but 1 square, that is same as 1. The left hand side is nothing but this into this. Correct. So this is a number with this number, a square minus b square formula. I get a square minus db square. Similarly, this bracket or this bracket will give me p square minus dq square. Correct. Now since my a, b and d are nothing but what? Integers, implies me my a square minus db square is also an integer. Yes or no? Since I know if a is an integer, a square is an integer, b is an integer, b square is an integer, also d is an integer. That means this part is also an integer. Hence, subtraction of two integers is again an integer. Okay. So I got to know my this first bracket is nothing but integer. Similarly, my second bracket is also an integer. Okay. Similarly, my p square minus dq square is also an integer. So I found this element into some other integer is giving me answer as 1. That means what? That means the inverse of this, my a square minus db square inverse is element of z. Correct? This implies me inverse is an element of this means what? I know that my a square minus db square is an element of what? It is invertible element, right? It has an inverse means what? It is an invertible element. That means what? It is a unit of z. Yes or no? I know this bracket is nothing but unit of z. Since I know after multiplying it with, I'm getting unity of that ring z. Right? Now also from this, I can conclude that since I know my units of z are what? There are only two units of z, plus 1 and minus 1. Yes or no? Yes. Since I know this is an element of this, I can conclude that my a square minus db square is equal to plus or minus 1. Right? So from this, whatever we have proved, I request student to go back to the video and just write all the proof or see it once and try to prove it by yourself. Read the question, just prove it by yourself. But now I know at least that my n of x will be equal to 1. My norm of any element will be 1 if and only if that element is the unit. Okay. I hope you will finish off this theorem in the good way. That means you will finish off, you will read it again. If you have any doubt, difficulty, just let me know in the comment section. It's a unit of z root of d. Okay. Now, in the next video, we'll be discussing how to apply this theorem in a different situations. One of the situation we will definitely learn, but for now, we know three properties that my n of x is equal to 0, n of x equal to 0, if and only if x equal to 0, right? We have the proof of it. Also, we know that n of xy is same as n of x into n of y for every element x and y for any element you have to consider. And the third and the most important one is n of x equal to 1 if and only if x is a unit of that ring. Okay. So after this, there is one more property that I'm not going to consider, but because it is about prime and irreducible. Definitely, once you know the idea of prime and irreducible, you should prove that property. You can search online. You can ask me in the comment section if you want later on. But for now, these three properties are enough for us. So thank you so much, guys, for watching this video. If you really like this video, just share it with your friends and subscribe to my channel. Okay. Bye bye.